Okay, so I want to share the vision of TempleOS. I said it. I said Linux wants to be a 1970s mainframe, and TempleOS wants to be a Commodore 64, a modern Commodore 64. So the user's guide for the Commodore told how to make binary graphics, how to use binary numbers to make graphics. So, like for example, let's say font. This is 64-bit, by the way. Let's change. How about let's change that? You can enter. I'm going to enter hexadecimal. How about FF? What? How about 3C, 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 FF. How about that? Okay, so I just changed a character. So that's what you did with the Commodore. Anyway, so the command line, the Commodore had BASIC at the command line, and you could enter programs. This has C, C++, Holy C. So let's say count. On the Commodore, you could enter a BASIC program into memory. With this, you can printf is doesn't require. So anyway, so this is 64-bit assembly, and it uses register variables. So then we can say count to 10. Okay. Now, whoops. What happened? Count to 10. What? Count. What did I do? Count 100. Oh. I didn't do a carriage return. So we got 0 to 10. Okay. I was scared there for a minute. Anyway, let's, okay, so the FS segment register points to the current task record, and if you say class rep D FS, then it updates the screen 30 times a second no matter what. So the whole screen gets updated 30 times a second. This is the task record, and this is a live widget. One of the fun things with the Commodore was you could put memory on the screen. And anyway, so I can change the window coordinates. Let's put a 5 here. Pow! I just changed a margin. Pow! I just changed another margin. Pow! Okay, so the whole purpose of the Commodore was for user developers, user programmers, and that's what we're trying to encourage learning. So there's a B drive, C, and E. I have a RAM disk, which is a B drive. It has drives like DOS. Anyway, this is a Red C file system drive. So what we're going to do is I'm going to hit Control D, and I'm going to take some files, put them on the clipboard, Control C, and then put them up here, Control V. So now I'm going to change directory to the B drive directory. So I'm going to say directory star comma true. This will list clusters. So now I'm going to do dump cluster. Dump cluster. And I'm going to give the current directory is here. This is the root directory. It happens to be 0x. And I'm going to write to it. So this is the whole purpose of this is to be simple for amateurs, for people to learn, like the Commodore. I used to undelete files by editing disk blocks on the Commodore. So this is the directory disk block. So how about if I'm going to change the name of this file. I just capitalized it. I'm going to hit escape, and it just wrote it. Now if I do directory, you see that I capitalized, localized. So so this is something no other operating system will let you do, obviously. Now I have a story. I have birds, and one time my birds were sitting on my monitor, and on my display, and I thought, boy, they have no idea what that display is doing. The bird has absolutely no concept, and I thought that was sad. If it's a human that doesn't know when they don't, I mean, come on, every kid should do this at least. Text, font, every kid. So let's give it a, I don't like what I have there. 0x, that's annoying. How about what do we want? We want how about 18, 0x 18. How about 00 18 00. Okay, oh, that's not what I intended. What was I thinking? Oh well. Oh well, let's. Oh, good enough. It was obnoxious. Anyway, that doesn't make sense, does it? Why does? Oh well. Oh, I was off by one. Okay, well, so the vision is to be hackable, and now it's now I have my Red Sea file system. I made the clusters basically block numbers, and I'm trying to make it simple, and I identity map all memory. So if you do a memrep, how about mem BIOS rep? So this is the BIOS memory report. Now I have virtual identity map to physical. So that means this map right here is actually the map of addresses. Anyway, it's 64-bit, and anyway, so another thing is it's ring 0 only. So that means you have full access to all the instructions. If you want to play with interrupts, you can play with interrupts. Now memory can get fragmented. It already starts out fragmented. There's breaks in the memory, and it doesn't use paging. It's identity mapped. So memory will get fragmented. At Commodore 64 and DOS, you used to have a reset switch. Somehow they Jedi mind tricked everybody into thinking it was a big deal to reset. They act as though DOS could never have worked with crashing all the time. That's not how it was. Neither was the Commodore like that. So I hope this. I've been having bad luck making videos. That's my flight simulator. I have tested. As far as I'm concerned, it passes all the tests. The measure that my goal is to. Whoops, what's going on? Okay, so my goal is to, this is a first-person shooter, and it's 590 lines of code. I think that's pretty extraordinary few. And it even has the graphics in the same file. So 590 lines of code, and it works. You know, you can, so that was my goal, was low line count. So one of the here's another one. The flight simulator is 968. It's multi-cored, and it has graphics and source code. Anyway, so since our approach is to load whole files at once, one reason is we have compression on an individual file basis, and that only works if you work with the whole file. And God said 640 by 480 is the 16 color is the graphics mode he wants. He said it's a covenant, and if that's true, then we're never going to have memory problems, because the only way you get memory problems is with multimedia and graphics and stuff. If you somehow, let's say you tried to be a clever thief, and I wouldn't really even care, but let's say you added a higher resolution graphics mode, well, the whole thing's going to fall apart, because it's not made for that kind of memory usage. It's for anyway. It loads whole files at once. One of the we can look at the view drive view B. This is the map of allocated files. So it doesn't have a FAT table. So if we go to it doesn't have a FAT table. It just has an allocation bitmap. So it's as simple as possible. When I design stuff, I think about it like a 1040 EZ tax form. You do not just add. It's a big deal if you add another. If you add another box to a 1040 EZ tax form, that's a big deal. So I think okay, well, there you can see I knocked off a few. Anyway, so we can even look at the allocation bitmap and learn about it. That's fun. We'll do that another time.